welcome to this lesson video for finding sine, cosine, and tangent of points that are on a circle. So we've been doing the unit circle in our previous videos, and so it's just kind of going to be an application of that, except our side triangle lengths are going to be different than the traditional ones we were using with our unit circle sides. So let's see what this is all about. You're given a point P, and it has the coordinates x comma y. So this point here represents the point x comma y. You went over x amount and you went up y amount. Theta here is our angle resting at the origin in the first quadrant, and r is just simply going to be our hypotenuse, okay? So we're going to be given x and y values, but we're not going to be given the hypotenuse. So we're going to have to use the Pythagorean theorem, Pythagorean theorem, to find the hypotenuse, and then it's going to ask us for, sine, cosine, and theta, sine, cosine, and tangent of theta, which is just simply, if we think about this as a reference triangle, the side on the axis is adjacent, r is the hypotenuse, this is obviously O, so sine is O over H, so that's where I got the y over r from. Cosine is A over H, so that would be x over r, and tangent is going to be O over A, which would be y over x, okay? So just a different way of looking at this unit circle stuff, like I said, that we've been doing a lot of. So the first thing when I'm given a point, okay, here's the directions. With the given point, find the missing side length of the reference triangle, and then find sine, cosine, and tangent of theta. So the point 3, 4, 1, 2, 3, 1, 2, 3, 4. I have to go over 3, up 4, and I get the point. So then I think about, our unit circle triangles, reference triangles. We would always draw the hypotenuse coming from the origin, and we would always either drop or raise our altitudes. Okay, so in this case I dropped. So here's where theta is, the angle at the origin. That's always the angle we kind of go from. That's our go-to angle. So what is the measure of this side of the triangle? 1, 2, 3. Well, it measures 3 because I went over 3 values for x. So x is 3. What is this height of the triangle? 4, because I went up a y value of 4. And so what's my hypotenuse going to be? Well, I have to do the Pythagorean theorem real quick. 3 squared plus 4 squared will give me my c squared. So 9 plus 16 will give me c squared, which is 25. So then I need to take the square root. This is an easy one. Square root of 25 is just 5. So if you're familiar with 3, 4, 5 triangles, you should have known that would happen. So then in respect to theta, okay, the side on the axis is adjacent, so 3 is adjacent, 4 is opposite, obviously 5 is hypotenuse because it's the largest side. And so do SOHCAHTOA. Sine is O over H, cosine A over H, tangent O over A. So let's see, O over H, 4 over 5 for sine of theta. Cosine would be 3 over 5, and tangent would be 4 over 3. Simple as that. Let's try another one. What if I give you negative 5, comma 12 as the point? So 1, 2, 3, 4, 5. I gotta go back 5, and I'm not gonna draw 12 tick marks. Let's pretend that that's negative 5, 12. Okay? So that, not good. There we go. Now we're back on. Sorry about that. So when I drop my altitude and I draw in my hypotenuse here, think about my side measures. This measure is negative 5. This measure is positive 12. I don't know the hypotenuse, so I got to do Pythagorean theorem. Make sure you use parentheses when you try to square that negative 5, if you're going to type it in a calculator. So let's see, I should have done this. X was negative 5, y was 12. This would be 25 plus 144, which is 169, which if you type that in your calculator, I believe you get a value of 13. So my hypotenuse is 13. Okay, so this is where theta is here at the origin, okay? So in respect to that theta, -5 is the adjacent side, 12 is opposite, and 13 is my hypotenuse. So again, SOHCAHTOA, O over H, 12/13, A over H, -5/13, and let's get that guy out of the way, O over A, -12/5. All right, one more. I'm gonna skip ahead till I find it. This guy, he looks fun. Plot the point 3, radical 3. So 1, 2, 3, square root of 3. Let's see. It's in between the value of 1 and 2. So we're just gonna guesstimate. It's about here. It's a little closer to 2, I believe. So draw my hypotenuse, drop my altitude. Got a small triangle I'm gonna have to squeeze. So there's theta. This value I went over was 3. The value I went up was radical 3. Now I gotta find the hypotenuse. So using Pythagorean theorem, 3 squared plus square root of 3 squared will give me c squared. So 9 plus, hey, you know what happens here? A square and a square root just cancel. So it's simply 9 plus 3 equals c squared. So 12 equals c squared, so I gotta take the square root. C equals square root of 12. But you know what? That's not simplified. I need to simplify my radicals because the directions will say that on like a test or quiz. So let me move that over here, and I gotta do a factor tree. 4 and 3 are the pair I'm thinking, and then 2 and 2. And by golly, looky there, I sure do have a pair. So this is really 2 radical 3 is my c value. 2 radical 3. Okay, so x was 3, y was square root of 3, and we found the hypotenuse r to be 2 radical 3. So in respect to this theta here, 3 is my adjacent, radical 3 is opposite. This is my hypotenuse. So the sine, O over H, I'm going to write underneath because I might have some work to do. Radical 3 divided by 2 radical 3. But hold up, wait a minute. Those radical 3's can cancel each other, and so what am I left with? Well, you know there's a 1 up top, understood, so I'm left with 1/2. Cosine A over H, let me give myself a little bit more room. Oops, didn't mean to do that. Well, I guess I'm kind of stuck. All right, that's okay. Let's see. Cosine A over H. So 3 divided by 2 radical 3. Uh-oh, this isn't good. With a radical at the bottom, daggone it. I'm going to have to rationalize. I'm going to multiply by square root of 3. And let's see what happens. Let's see. On the top, I've got 3 radical 3. On the bottom, I've got 2 times whatever radical 3 times radical 3 is. Well, let's think about this. Square root of 3 times square root of 3 is square root of 9, which is a 3. So I'm just doing 2 times a 3, which would give me 6. And then I can reduce that, and that reduces to a radical 3 over 2, because you know that would be like a 1 on top, which is understood, which I don't need to write. Man, oh man, let's hope tangent was a little bit easier than that. Whoops, I guess that C is part of that down there. Ah. There we go. Tangent is O divided by A, so radical 3 divided by 3. Well, there's nothing wrong with that. There's no radical at the bottom, so that's just my tangent value. Awesome. Didn't have to do anything with that one. Okay, so that's about as complicated as they get when you've got to simplify your radical down here, and then you have to rationalize for some of your trig values. But that's the basics. When you've got a point, just draw the reference triangle, and then you just go through the OAH, you know, the SOHCAHTOA stuff, like we should be used to. But I think that finishes me up for this video. Yep. So next video coming up is going to be looking at 6 trig values instead of the 3 that we're used to. So that's it for this one. I'll see you next time. Keep learning and have fun.